This is the Amp Hour Podcast, released June 24th, 2018. Episode 397.8. An interview with Chris Gerlinsky.
Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Chris Gerlinsky, a hacker on Vancouver Island, Canada.
I like that. You self-identify as a hacker. That's, I think, our first one this weekend.
Oh, that shocks me, actually,
Yeah,
given where we are.
Yeah. So what kind of hacker are you?
I do embedded reverse engineering.
Nice.
So I do firmware disassembly, and then I do some hardware level stuff where I'll do IC decapsulation.
That's awesome.
And some delayering and imaging with microscopes.
Yeah.
Sometimes I get into some microprobing.
Wow. Okay. So where to start with that? How the hell did you get into that? That is so cool. So actually, Bunny, who was giving a talk here at TourCamp, he was showing some of these things, and I was looking at it and just like, my God, I can't believe you pull stuff out of there. You're looking at the silicon, you decap it, then you look at the silicon, and then you're actually able to pull stuff out of there.
It is awesome, isn't it?
So like, what, how, wait, where, why?
I developed an obsession with this at a young age.
Okay.
In my teenage years, there was a lot of pay TV satellite piracy going on in North America. And by chance, I
all
happened
for
to be...
HBO, huh?
That's right. Nothing's as good as free HBO.
Yeah, that's right.
And I just happened to be, by chance, close to some of the people that were involved in that. And there was a lot of interesting technical challenges. And I met a lot of people on the way and was able to get training from some of the other hackers that were in the pirate business.
And so the same thing happened there, though, too. So like that's where, I mean, I've heard about these kind of like exploit. I think maybe Dimitri, who we both know and has been on the show, Dimitri Nedespazov, I think he was telling me about some of the pay TV stuff as well.
Yeah, we have a lot of mutual contacts and mutual stories.
That's an interesting like kind of realm. Like, I mean, I knew there was the hacking community around it, but like, I didn't realize it had to go so deep to get at some of these security things.
Right, yeah. In Europe in the mid-90s already, there were guys with setups in their garage that were doing the whole lab thing, decapping chips and microprobing and all of that kind of stuff. And the pay TV market, back when it was still very lucrative, there was a lot of desire for the pirate cards and stuff. So it even got into people using equipment like electron microscopes and focused ion beams for modifying chips.
Okay.
Yeah.
So, and what is you said microprobing? What does that actually mean?
So with microprobing, I decapsulate the IC to remove all the plastic off the top and expose the top of the chip. And then the top layer of the chip is a kind of a glass layer known as the passivation that protects the chip. So I have a laser attached to the microscope that can selectively remove a small area of this passivation, and that exposes the metal lines below.
Okay.
And so at this point, the chip is basically a tiny miniaturized version of a circuit board.
Right, exactly.
So I have needles on micropositioners that allow me to
you really dial it in.
Dial it in, and you have micron accuracy with that.
Really?
And you can physically contact the wires on the chip and read out some of the internal signals.
See, I always wonder about that too, because I even see like firmware dumps and just like thinking about going through all of that stuff too. But then when you're decapping a chip, I mean, are you starting with like a family so you understand kind of where things should be generally in the topology? Or are you doing X-rays to kind of figure that out as well? How do you know where to start when you're doing that?
When I'm looking at a chip, the first thing that I want to do usually is get the software out of it.
Okay.
So I'm looking for the ROM, EEPROM, these kinds of
big
memories.
Blocky area.
They're super easy to see on a chip.
Okay.
Yeah.
Okay.
Big blocky areas.
So you'll take two chips. The first one you'll get all the way down to the silicon. Look at that under a microscope. Say, oh, it's over here, and then do another chip.
Exactly.
Okay. How often is it? Is it always like chemical based to get the caps off, or how you?
The processing that I'm using is chemical based. There's other types that are used in industry. Some people do laser decapping.
Okay.
Generally, there's chemicals involved. That gives you the cleanest result. For the delayering, to actually strip down the layers off of the IC, there's wet etching with chemicals. There's lapping or polishing physically.
Yep.
And then there's plasma etching, which is also used.
It's basically making a chip in reverse, right?
Exactly. And a lot of the tools that we use for taking it apart, we look at the failure analysis equipment that's available.
Oh, wow.
Because, if they build it, they have to be able to take it apart to find out where they messed it up. So we just sort of piggyback on those tools.
That's great. Okay, so now you have a chip, you've taken the top off, you started to probe in there. So like, how do you actually remove the software, pull the software out of there? So what does that process look like?
So this depends on the chip. If it's a ROM-based chip, that means that the bits are physically encoded on the chip. So when you start stripping layers off of the chip, depending on the manufacturing process they use, because they have different styles of ROM that they can design, while you're delayering, at one point you'll be able to identify the bits. You'll see that there's two different states within this large memory block. So you can guess that one is going to be 1 and one is going to be 0.
Okay.
Some of them, there's some pretty significant processing involved in being able to make the bits actually visible under the microscope. But the basic idea is that you you delayer until you can see the bits, and then once you can see a difference between ones and zeros, it's just a matter of pulling them out.
I think it's the seeing the bits. I'm doing air quotes, people can't see it, but like seeing the bits is kind of an interesting idea to me. It's like, oh, I guess there are things that you can see. So is it like, it's not IR based, like is it like you're looking at it under a microscope and you're seeing these differences between one spot and another, and then you're taking a picture and then kind of post processing?
Exactly.
Oh, it is, okay.
Yeah, and so in some cases it's a matter of whether they have a metal line connecting to parts within what makes up a bit, or in some cases it's whether they added a dopant to make a transistor actually work or not.
I got it.
Or sometimes it's whether they put the via layer in between, the plug in between the two layers or not. So depending on the type of the chip, it's going to look different. But at the end of the day, it's physically encoded into the ROM. So there is a way that you're going to be able to see those bits and then pull them out.
And so like how long will it, like a standard, I mean, I'm sure everything's different, but like a standard, if you had to take a guess, if you were going to like quote to a customer how long it would take to reverse engineer something, is it like 6 months? Is it a year? I don't, 3 weeks? I don't know.
It's so hard to estimate. Every project is so different. For extracting a ROM memory that's relatively simple, usually a couple months gives you enough time to kind of study it and everything. If it's a really custom SoC and you're trying to get more than just the ROM out of it, then 6 months or a year, it's pretty easy to spend that time that's learning. And
like how many do you need to have on hand? So that like, I can imagine just like polishing one and be like, nope, that didn't work. Do you need to have
a lot
like,
of that?
Like a pile
ideally
of chips?
you have a big bucket that you can pull chips out of.
Okay, that's good. That's good. Okay, and so but you said embedded, but I mean like, and I realize that you're saying you're getting to code and pointing that out, but like that sounds like pretty hands-on physical kind of stuff, right? I mean, so you're doing this just to get the code out, and then what? I mean, like then what do you do with it?
This depends on the project for the customer. Recently, I've been working a lot with aftermarket automotive companies, so they're interested in getting this code so that they can make their own parts that are able to be added into the vehicle and actually link in with the ECUs and everything inside the vehicle.
Oh, interesting. Okay.
Yeah, so sometimes there's a secret key for an algorithm that they need to know so that they can talk to the rest of the vehicle and say, oh, this is a valid part in the vehicle, and you should continue to operate normally. Because
they're just very closed systems, is that kind of the idea?
Yeah, everything is so closed and so proprietary. So it's about being able to find what's proprietary and how to integrate with that.
Interesting. So then, like do the aftermarket systems, is it because they're so outside the sphere of the automotive companies that it's just the end users using it? Is that the idea?
That's the idea. Yeah.
Okay. Well, that's great. I mean, like that's a really interesting. I mean, like. Well, I mean, you and I were camping next to each other, and we didn't know. I mean, we just met in the last day. We just had closing ceremony, so like, yeah, it's great that we're talking about this. But man, that is crazy. So, what are some of the challenges that you encounter when you're kind of diving down through these layers of physical chip? Like, what is your daily challenge?
The process size for these chips keeps shrinking, so it's getting tougher and tougher. For me, generally, I'm looking at chips that are a few years old, and I look at a lot of smaller microcontrollers.
Okay.
So I'm still able to get away with relatively Stone Age equipment as far as chip fabs go. For anything really modern, you start needing a scanning electron microscope to even be able to image it, because the feature sizes on the chip are so small, it's below the wavelength of visible light, so it's just impossible to even see without an electron microscope.
And so people are actually starting to. So there's obviously more of where you came from, right? It's like a interesting look at that. But what are some of the other tools that they need to have on hand in order to do this kind of work?
So you'll have a chemical lab so that you can do the decapsulation of the delayering using chemicals like fuming nitric acid and hydrofluoric acid for delayering the chip. Typically you'll have a chip polisher or lapping machine for delayering. Plasma etchers are pretty useful too.
So
for
just buying remaindered equipment, that kind of thing?
Yeah, it's incredible what you can find on eBay these days.
Yeah, that is crazy. Okay. Wow. So you mentioned you actually gave a talk at CCC.
Yeah, at 33,
2 years ago?
33C3.
Okay.
I did a talk about reverse engineering the Motorola cable set-top boxes.
So what are those?
So most of the cable companies in North America are using a system based on, originally it was General Instrument, then they got rebranded to Motorola. These days they're Aris. And so these cable boxes have a security chip inside to decrypt all of the television that's coming down.
Okay.
Because the cable company is always sending you all of the channels over your wire.
Right.
But they're
just selectively pulling off the bandwidth.
Exactly. Yeah, they're encrypted in a way that you can't get them unless you have the authorization for it. So I had a past messing around with some pay TV security related things. And so I started looking at these boxes, and they came out in the mid to late 90s.
Okay, so this is like old tech. You're
exactly.
Like, okay, so this is stuff you're willing to talk about because it's
well, they're still using them though.
Yeah.
It is still active.
Okay.
Yeah, because the system was never really pirated or anything. So the existing boxes are still, they're a newer version of the chip, but they're working in a compatible way. And a lot of the cable operators, like mine at least, you can still use the boxes from the 90s, and they'll still authorize them, and they still work perfectly fine.
Really?
And they.
So what does that look like on the security side of things? It's like they basically like authorize, so like they understand that there's a box out in the field. It does like some kind of handshake thing and authorization, or?
It's one way actually.
Okay.
Most of the cable systems do have the capability for two-way, but for your basic TV packages, anything except for the video on demand, and that has to be necessarily interactive.
Right.
But for the rest, they can do it all in one way. So the underlying signals are very similar to on satellite TV, which is also one way. So each box is individually addressable, and then the cable company will send your box a message, and it will say you are authorized for these channels XYZ, and there's a secure chip inside of the box that remembers which channels you're authorized for, and along with that list of authorized channels, it gets the encryption key that allows it to decrypt channels for the next month.
Got it. Oh, and so that's a regular update type thing.
Exactly.
Okay. So I was wondering, because I was wondering mostly like how like an older equipment like that would still be valid over time, but if the updates are still coming through, then it's really just about the encryption algorithm internally has stayed the same.
Exactly.
And then that's the decryption path.
Right, yeah. They've kept it compatible all the way through. They don't have to change out all their customer set-top boxes. There's still people using boxes from 20 years ago.
Wow. And so then that means that you were basically, so did this thing you did like kind of obsolete some of the stuff they have then, or how does that work?
The pay TV industry has kind of obsoleted itself.
Oh, okay, all right. So basically it's a little bit less out there than it used to be, right?
Yeah, and I explained my process to do it.
Yeah, right.
But most people aren't delayering the chips in their garage and getting pictures of the ROM to extract the code and pulling the keys out.
Okay.
So like in my talk I explained the process, but I'm not actually sharing the encryption keys and things like that.
Yeah,
or anything
sure. No, but that's the interesting things that people would be interested in anyways. So in that case, that was about like the same thing of delayering and then finding out what the encryption key was, and then that ultimately was the thing that allowed unlocking.
Yeah, once I'm able to pull out all of the keys from one of the set-top boxes, if I do that from one box that's subscribed, then conveniently the cable company sends me the new keys.
Right. You can start to watch the pattern over time, and yeah. Here's a real question though: is if you have access to all the channels, can you still find anything to watch on TV?
It's only worthwhile as a technical challenge.
Right. Yeah, that's funny. So how does this translate then? So is it the automotive, like you said, it's automotive, but it's aftermarket stuff. So what layer of the automotive does that actually live at? Is that something on the CAN bus, or is that?
Yeah, generally I'm working with devices communicating on the CAN bus and figuring out some of the challenge response systems that are in place that allow two ECUs to connect to each other. Okay,
and I learned the term ECUs from the Machina guys who were on the show, but ECU is not, and I think Rick Alter also talked about that, but ECU is not necessarily just the engine control unit, it's also just a generic computer unit, right?
Right, yeah, generic control unit inside the vehicle. And there's several ECUs for everything from your engine and your transmission to your ABS to the immobilizer system for the keys.
Oh, okay.
to in the dash. There's a lot of them these days.
So what is security like in general? Like, so you're seeing probably a lot of security in different types of cars these days. What is the state of security in automotives?
There's definitely been a trend over the past few years for them upping their game.
Okay.
Everything used to be pretty trivial.
Yeah. Okay.
And it's
1, 2, 3, 4, 5.
Yeah.
Spaceballs. Yeah. Code.
And there really were seed key challenges where if you logged a dealer's tool a couple times, just looking at the messages it was sending, you could guess the algorithm in some of them. It used to be that simple.
Wow.
Now they're moving into signed code inside of the ECUs.
Oh, what does that mean?
So having like an RSA signature on the code that the boot ROM will check, and if you modify the code inside the ECU, then it's going to refuse to run.
Oh, okay. Yeah, so that really starts to, the tinkering is cut down.
Yeah, they've really upped their game. Yeah.
Okay. Huh. I guess there's bigger money and there's more capabilities to do that kind of thing. So how does that change your challenges then? Like, does that mean you need to pull more information out?
Yeah, the challenges have gotten a lot deeper. Trying to find bugs in their code. At the end of the day, you're still searching for bugs, and the software's pretty complicated inside of a lot of these units.
Yeah.
So generally, it is possible to find some kind of a bug. It can be tricky these days.
So do you do that thing where you're trying to you're fuzzing and trying to get ROM dumps as well, or how are you when you finally get to you're trying to get the code out, but you're also trying to get the keys out, right? So is it harder to get that to kind of to get the code out? I guess I'm stumbling over my words here. So you're able to look at certain parts of the code and get the keys out. But then, are there other methods to get the rest of the code out and get memory dumps and stuff?
A lot of the parts that I work with tend to be the less sensitive areas, so that's a lot more convenient to work on. And a lot of those, it's not so hard to extract the code out of the chips inside.
Okay.
Except for in the engine control modules, they're starting to use higher end chips with more security. But your typical microcontroller, it has some lock bits that you set to block readout, and most of those aren't really that difficult to disable if you can start opening the chip up and poking at it in a lab.
Okay. Yeah, so what does your lab look like? I mean, so obviously you mentioned a lot of the equipment here, but you're up in the Victoria, what was it called?
Yeah, I'm outside of Victoria on Vancouver Island.
Vancouver Island, yeah. So your lab is like a car hacker's paradise, or what?
So in my garage, I have on one side I have the hoist, and on the other side I have the clean room in air quotes.
Okay, yeah, right. The not car side, right?
Right, exactly.
Yeah. I mean, I've seen OBD2 type plugin stuff. Is it you're actually pulling entire assemblies out when you're getting in there, or how does that work?
Yeah, usually I work with everything stripped out of the vehicle. I tend to work at the lower level, and the companies and the other engineers that I work with tend to do more of the integration part of it. Okay.
So you won't you're not are you tapping off these cable assemblies? I've seen the cable assemblies before, and those are insane. Is it basically pulling off those, or is it more the actual? Are you directly on the devices? How much?
A combination of both, really.
Okay.
With some of the projects that I've worked on, even they just send me the code out of the chip and to study the code. They just need some answers from within the code, so I'll disassemble that and try and find what's inside.
Yeah.
Or sometimes it's tapping into the wiring harnesses and this kind of thing.
Yeah. I guess I wonder, I guess what I'm really asking is, how in situ does the testing need to be? Is it you need to be running other parts of the car to be interacting with it, or are you kind of throwing it into simulation and seeing what happens?
As much as possible, I work in simulation. At a certain point, you have to try on real vehicles, that's always a challenge with the automotive stuff, to have access to all the different vehicles you want to test on,
and
to be able to work with them with the possibility of causing a problem on it too.
Right, yeah, if you're riding in it, it's kind of dangerous, huh?
Yeah.
Right, you have wires coming up from the console, and yeah, that could be a little frightening. Depending on what services you're working on, right? Brakes are a little bit more high stakes than infotainment.
Right.
That's cool, man. Yeah. So you said you went from the set-top box realm, but how did you start with the car? Are the challenges similar enough in the automotive world? How did you make that leap in automotive?
Yeah. So in automotive, because they've been stepping up the security levels, there's been a lot more interest in finding people who are capable of doing the reverse engineering, the disassembly, extracting code from chips, and these kinds of things. And there is some supply of people doing that kind of thing from the pirate satellite world.
Yeah.
And so there's sort of a natural crossover there where the skill set matched up.
That's super cool. Are you building? Do you have to build any hardware in order to assist with this stuff, or is it more like disassembly versus having tool sets?
Mostly, I'm working on disassembly. I build a lot of little breadboarded stuff. Yeah, exactly. Yeah. Interfaces and that kind of a thing. But yeah, most of it is just the reversing part.
Awesome. Well, this is super cool. Where can people find out? I don't know. Are people able to find out more about you, or is this more of a...
Well, I'm on Twitter.
Okay, great.
AKA Caster.
Okay, great. We'll definitely link that in. That's awesome. And you do obviously publish about your work at CCC and other places?
Yeah, you can find that on YouTube.
Yep. Other security conferences in the future as well?
I'm a regular at Recon. I was just there last week.
Montreal
that
last
was great.
week.
Yeah, it's always a blast.
Yep, that's cool.
And TourCon also is always a good one. Yeah.
Okay, cool. Yeah, this is a space that obviously I was stumbling a little bit about. Like, I mean, I don't even know what to ask. Like, this is just so weird to me that like, oh yeah, people do this. It's like a job, of course. Yeah, of course. Just pull codes out of chips. Most days I can't figure out how chips work, let alone like.
I'm in the same boat some days.
Yeah.
And I just sort of fell into this really.
Yeah.
I enjoy the work, and the more I do the work, the more opportunities have fallen into my lap.
That's great.
And it's been a blast.
And you are a member of, there's a hackerspace on the island, you said?
Yeah, there's a makerspace that I'm part of, makerspace in Nanaimo.
I don't know how to spell that. I guess Nanaimo?
Yeah, Nanaimo.
Okay, that's great. Well, shout out to those guys. Hopefully they're...
Yeah, we've had a great group up there.
That's awesome.
It's excellent.
Yeah. Well, thanks for joining me today, and I'm glad we got to meet each other at Tour Camp.
Yeah, it was really great to meet you.
Okay.